We're going to have a look at some Hess's law questions. So this is where we indirectly find out the enthalpy change of reaction. So without doing an experiment, we can use data to work out the enthalpy change of a reaction. So we're going to have a look at 3 examples. We're going to look at how to construct the Hess's cycle, plug in numbers, and then get our value from that. So this first question over here, we've been given some data and we've been asked to work out the enthalpy change in reaction for this reaction here between ammonia and hydrochloric acid to form ammonium chloride. So what I'm going to do is I'm just going to rewrite that equation over here, slightly bigger, but I'm also just going to not put in the state symbols because they're not really necessary at this point. Okay, the main thing is that this equation must be balanced. Right, so this is the equation that we want to work out the enthalpy change of reaction for. So this here is our unknown. This is our enthalpy change of reaction that we don't know. So I'm just going to call it X. Okay. What I then need to do is look at the information that's been given to me. Okay, this information here is the enthalpy change of formation of these compounds here. It will be given to you in the exam. You're not expected to memorize any of this data. Chemists usually get it directly from a data book. But as I said, it will be given to you in the exam. You just need to know what to do with it. So if they give you enthalpy change of formation, that means at the bottom of your Hess's cycle, you need to write elements. Okay, so if you write elements at the bottom, if you're doing enthalpy change of formation, it always goes from your elements to the compounds. So that means all my arrows in this Hess's cycle must be facing upwards. And that's very important. Otherwise, you will get incorrect values. So all of my arrows should be pointing upwards. What I'm then going to do is look at the molar ratios and plug in my numbers from my table over here. Okay, so this is all to form 1 mole of each compound. So over here, I'm also forming 1 mole of ammonia. So on the arrow, I'm just going to do minus 46. To form 1 mole of hydrochloric acid, that's minus 93. And to form 1 mole of ammonium chloride, that's minus 314. Okay, all of these are in kilojoules per mole, but I'm not going to put the units in until my final answer. So that's our Hess's cycle constructed. We now need to know what this actually means. Okay, so if you remember, Hess's cycle or Hess's law states that we can indirectly work out the enthalpy change. So we can't do this directly. So we're going to take an alternative route. We're going to go from our reactants down to our elements, which are our intermediates, and then we're going to go up to our products. Okay, so we're going to go via this route because it's going to equal this route over here. So that means I want to go from my reactants down to my elements. So I'm going to go in the opposite direction of these blue arrows here. If I go in the opposite direction of an arrow, I must change the sign of the value. Okay, so down here, I'm just going to write what I would type into my calculator. So if I'm in the opposite direction of this, that becomes positive 46. And if I'm going in the opposite, remember I have to add both these arrows up. If I'm going the opposite arrow of this direction, that becomes positive 93, so plus 93. Okay, so going down both those arrows, I am now at my elements. From my elements, I now want to get to my product over here. So I'm going to go in the same direction of this blue arrow here. If I'm going in the same direction, the sign of this stays the same. So that is minus 314. If I plug that into my calculator exactly how it is, that gives me a value of minus 175 kilojoules per mole. Okay, so this route over here is minus 175 kilojoules per mole. And according to Hess's law, that means that this route here, my X route, is also minus 175 kilojoules per mole. So this is the enthalpy change of reaction for this top reaction here. Okay, and as you can see, it's an exothermic reaction because it does have a negative sign. And that's how you do it for this question here. Let's move on to another question. So again, they've given us the enthalpy change of formation data and the equation, and we're being asked to calculate the enthalpy change of reaction for this reaction here. So again, I'm just going to rewrite that equation. And as I said, state symbols aren't very important in terms of constructing the Hess cycle, so I'm just going to leave them out for now. As long as your state symbols here match the state symbols of this data here, which they do. Okay, and again, in terms of the information they've given us, it's enthalpy change of formation. So that means at the bottom of my Hess cycle, I'm going to write elements. And if you remember, all my arrows need to be pointing upwards. So I'm going to draw an arrow going upwards to all of these compounds here. And then I'm going to put in my values for each of these arrows. So this one going from elements to ammonium chloride, it's 2 moles of ammonium chloride. So it's going to be 2 lots of minus 314. So I'm going to do 2 lots of minus 314. 1 mole of calcium hydroxide, so that's minus 986. Calcium chloride, 1 mole of that, so that's minus 796. Make sure you remember which numbers to which arrow. This arrow here, so 2 moles of ammonia, that's 2 lots of minus 46. And 2 lots of water, so that's 2 times minus 286. Okay, so that's my numbers plugged in. And just to remind us, we can't directly work this one out. So this is our x, this is our unknown. We can't directly work out this route. So I'm going to go from the reactants down to my elements and then up to my products. I'm going to go via this route. Okay. So in terms of what I'm going to plug into my calculator, if I go from my reactants to my elements, I'm going to go in the opposite direction of these arrows. So both of these arrows here. So I'm going to change the sign of both of these. Okay, so this one over here, if I change the sign, it's just 2 lots of positive 314. And in the opposite direction of this, it's positive 986, so plus 986. Okay, that then gets me to my elements. I now want to go up all 3 of these arrows. Okay, so if I'm going in the same direction, the sign for them stays the same. Okay, so this one here, the sign stays the same, so it's minus 796. Again, up this one now, the sign stays the same. I'm just going to take the minus out of the bracket, so it's minus 2 lots of 46. And the same thing for this one, same direction, so the sign stays the same. I'm going to take it out of the bracket, so that's minus 2 lots of 286. If I plug this exactly how this is into my calculator, I get a value of positive, so I'm going to put the positive sign in, 154 kilojoules per mole. Okay, so it's an endothermic reaction. This route here is positive 154 kilojoules per mole. According to Hess's law, as long as the conditions of the starting conditions and the final conditions are the same, this route here equals this X route here, and therefore the enthalpy change of reaction for this reaction here is also plus 154 kilojoules per mole. Okay, moving on to the last question here. So this one, we're working out the enthalpy change of reaction of this reaction here. Again, I'm just going to write it out. Okay, and again, because we've got enthalpy change of formation data at the bottom, I'm going to write elements, and all my arrows should be facing upwards. Okay, the thing to remember here is if you've got an element up here, which I do have, you don't need to draw an arrow going from the elements to the element, because the enthalpy change of formation of any element is just going to be 0, so therefore you don't need to draw an arrow for nitrogen here or for copper here, because they're just pure elements, they're not compounds. So I just need to have an arrow going from here to ammonia, to copper oxide, and to water. Okay, so now again we're just going to plug in our numbers. So the formation of 2 moles of ammonia is 2 lots of -46. Formation of 3 moles of copper oxide is 3 lots of -157. And the formation of 3 moles of water is 3 lots of -286. And again, this is our x, this is our unknown route, so we can't do it directly. So I'm going to go via this indirect route, via the elements, up to my products. Okay, so in terms of what I'm going to plug into my calculator, I'm going to go in the opposite direction of these arrows to get from my reactants to my elements. So I'm going to change the sign of the value. So going in the opposite direction of this, it's 2 lots of +46. And again, change the sign of this arrow. So that's plus 3 lots of 157. I'm now at my elements and I only have 1 arrow to go up to get to my products. The sign stays the same. I'm just going to take the minus sign out of the bracket. So that's -3 lots of 286. If I plug this in exactly how it is into my calculator, I get a value of -295 kilojoules per mole for this route. And according to Hess's law, this route also equals this route here. So my enthalpy change of reaction for this reaction here is -295 kilojoules per mole. And it's an exothermic reaction because it's negative.